It already looks like quite a few folks have joined, so I think we can go ahead and kick this off to stay on time, given I know folks are joining from a variety of time zones. My name is Nick. I'm responsible for marketing at SigOpt, and thank you all for joining us for this webinar that will focus on scale and some of the barriers to scale in machine learning, and how some tips and tricks, practical tips and tricks, as well as some software tips and tricks that can help you overcome some of those barriers. During the course of the webinar, I'm sure everyone's familiar with Zoom at this point in time. So use the Q&A functionality within Zoom to ask any questions. I'll be keeping track of that, and will likely end up interrupting the conversation, provided that the question is topical for the subject at the time, to make sure that we can cover it as we're going over that particular section itself. So we will be doing questions running through the course of the webinar. I will also be bucketing a few questions for the end if it's not going to quite fit in the flow, or if we've already moved on from that section. So feel free to engage. We'd love to have any questions from you through the process. Really quickly, I'll do a brief introduction of our two panelists today, and then I'll largely just take a step back and let them go forward, because they have many more interesting insights to share with you than I do today. So today we have Rob joining us from Slalom. You see his title there. And I will only highlight that Rob has most recently been responsible for building out the APAC region for Slalom. So, bringing a lot of expertise he has from operating in North America to APAC as well on behalf of Slalom. Our second panelist is Faye from SigOpt, and she runs product for SigOpt, and has most recently been focused on launching new products that make it much easier to track training runs and to visualize training runs, gain insights on model behavior through the entire model development process in a way that's very seamless and easy to integrate in your workflow, alongside the hyperparameter optimization solutions that SigOpt's known for. I will post, you have their partial bios here. I'll post a link back to the sign up page where you can find their full bios if you're interested in learning more. I'll make sure that's available in the chat. So from here, I'll let Rob and Faye take it away. Thanks, guys. And Rob, I believe you're still muted, just saying.
All right, good. It doesn't get old. We're all still learning how to use Zoom. Hi, everybody. Good afternoon, good morning, depending on where you're at. While we're used to clothing changes, the new norm of COVID, I also feel like I need to recognize the mustache. Movember is a very, noteworthy cause, very large here in Asia Pacific, but growing in the US. So the fine mustache is not a statement as much as it's a, I'm sticking behind the Movember cause. So anyways, let's get a little bit into the topic. Let me briefly introduce Slalom. Slalom is a consulting company. We just opened up in Asia Pacific, but we've been in the US and Canada and the UK for 20 years. My team, the data and analytics team, we look over everything from your information strategy to your Tableau data visualization to data engineering. What we're going to focus on here more is how I've helped some of our clients work with, getting some value out of the ML engineering and data science area. One of the things, if we look at kind of the hype and some of the energy around, what a technological advancements in a business such as machine learning models can provide for a business competitive advantage, you start looking at cases where sometimes it's not about the innovation itself. It's about how you're able to scale, reproduce, and absorb that innovation into your organization. Whether you look at some old school examples of beta versus VHS, or you look at more modern ones on the push that Tesla has been making to try to take their market share in the automobile industry. The challenge isn't about the innovation. The challenge in many cases is about the scale. And ML is not different. You look at Facebook and Apple and Google and many others. It's not a one-hit wonder. The ML has been built up on an infrastructure, many layers of innovations that they've invested quite a bit into building. And we can loosely call this ML ops, but it's really about that infrastructure and capability within their organization. As more of my clients and many of you start to explore ML, you're going to start hitting the same sort of challenges as you start trying to get that scale and that reproducibility and returns. And we're going to talk a little bit about that. First, let's take a step back. Let's look at the generic, if you will, ML delivery lifecycle. Many of you are familiar with it: train, package, validate, deploy, and monitor the models. You might have even worked out the need to retrain models, and you might have even been able to automate a lot of that, which would be awesome. But a lot of our data science and machine learning kind of teams that we work with, you start tagging on data management needs, model management issues, auditing, logging, governing, security. It starts becoming a bit overwhelming. You add on some additional complexities around the fact that a lot of these processes are manual. You start looking at, this is spread across a number of libraries, a number of packages, platforms. You're looking at on-prem cloud. You start looking at the need to work within different, say, organizations. If I look at, ever since Apple opened up the coffer a little bit and exposing us, we start looking at how the Siri platform is operating. There's 100+ data scientists contributing to this platform across many geographies. You look at the high level, there's about 7 layers of this model, starting with the first layer, which is kind of your false trigger model. This isn't a one-hit wonder. The ML ops that makes this work so that you can submit variations to any one of these models and test it or validate it across this whole ensemble or multi-mode inference environment, that's not trivial to do. That complexity has been built up to be able to sustain that kind of return that they're getting from the Siri model. Add in the complexity of deploying it to your phone, and that's a whole nother layer that they've had to accommodate. Fortunately, ML ops here can help try to solve that problem. You want your data scientists and your ML engineers to focus on the core of what they're supposed to focus on. ML ops is really trying to bring some reproducibility in ways that software engineers have already been kind of enjoying. Worry less about production ready code, spend less time building up the data pipelines. Look at that, faux pas number 2. And standardize the way your team collaborates, which I think is something that's really going on. You silence the phone, but the connection to the MacBook is not silenced. I think one of the other issues is nowadays we're recognizing that finding the right skills for your engineers is also going to be really difficult, but is not as much of a difficult now with some of the tools that are available. So we're reducing that skill gap for onboarding new team members. So we have a number of positions on how ML ops can be, helpful for you. But let's face it, not everybody's Apple and Facebook. You need to measure how much governance and how much ML ops capability you need to build up based on the problem in the real world situation. How much of your data ingestion is going to be manual versus automated? Is there feature engineering a standard process, or are you going to build out a feature store? You also look at single model versus multi-model management from, are you going to go for the Siri model, or is one support vector machine enough? One of my clients, pulling from a very, very, very large set of data, needed to come up with new ways of sampling data for the retraining. And in their situation, they couldn't just use stratified sampling. They wanted to make sure they had a representative set of data, but it was too large to technically even go through there. So we had to add in some extra complexity around using Markov chain, Monte Carlo sampling to be able to pool statistically what we felt like was a better representation of data from a smaller set. That, of course, adds more complexity to the situation. But thankfully, tools and processes are out there to help us out. And I'm not saying that the silver bullet is go find a great tool, but it helps to lower the entry barrier here so that you can start to leverage some of these benefits that the big guys like Apple and Facebook have had over the years. So we take our core pipeline, and I usually start there, and we sort of talk about that with our life cycle. Then the section is, how do I start to overlay certain features that help me build out this ML ops foundation? Code repository, log storage reporting, fault crash monitoring, and of course, orchestration, whether it's MLflow, kubeflow, or airflow. Then we start looking at how do I either acquire tools or build capability around environment management. You might have Anaconda on your laptop, but how do I manage all those different versions and libraries and coding languages up on the cloud? How do I make sure I got the security in place and a scalable inference and training infrastructure? And then where our friends SigOps are coming in, we start getting into model optimization components. how do I need to get a better sampling strategy in place. I need to manage the experiments and variations that I have of the models, monitor the performance drift, and of course, hyperparameter optimization. Again, more complexity, but we have tools and processes and frameworks that can help manage a lot of that and make it a little bit more approachable. And then the last one I kind of throw in here is really around, for more mature capabilities in some organizations, you want to start pushing the innovation outside of your kind of R&D team and start putting it in the hands of the business. So model libraries where the HR team can borrow segmentation models that have been built and pre-trained from the marketing and sales team. So you might start leveraging something like a model library or auto ML capabilities that are out there that are actually great for POCs and proving the viability of certain modeling situations. And lastly, let's not forget about AWS Neo and other tools for deploying your model into the Raspberry Pis or phones. So there's a lot of things that go into building out this MLOps capability. What I'd say is start with this kind of framework and then start prioritizing the build out or the investment of capabilities in these components. And you'll start to look a little bit more like the MLOps platforms that the big guys enjoy through many years of investment. Now you might say, kind of, where do we start? The typical consulting slide, let's boil this down to roughly 5 areas. A lot of times I say, look, let's focus on the data ingestion. Let's try to automate that. Let's make it so that you're not manually walking through a Jupyter notebook. Let's build that pipeline and maybe leverage something like feature stores. Let's automate the release process, proper DevOps, containerization, being able to deploy it up to the cloud or other multi-platforms is going to be critical. Serving it, and then of course reproducing any kind of experiments that go through and results. As part of that, you might also start pulling in some stuff around transparency, interpretability, and then last but not least, obviously strong model development. Being able to monitor the model from a drift perspective, but also from a just performance and training across multiple experiments and variants. And then last but not least, model optimization, finding tools that can help you with that, get around the brute force methods that are still being used quite a bit, or gut, optimization, especially when you start getting into multiple features, you're going to need to start looking for different ways of doing that. So with that, I'd love to have a further discussion and dive into more of this and how we can help out from a kind of advisory perspective or solution perspective. But I'd love to kind of maybe then hand over now at this point to Faye and just hear about how SigOpt is helping many of their clients, across the world deal with some of these issues.
Excellent. Well, thank you, Rob. If I may, I'm going to share my screen.
Okay.
Great. And let's actually do that so it doesn't get in the way. There you go. Okay, do you guys see my screen?
Yep, good to go.
Excellent. All right, so I thought I'd share with you a little bit more about how we got to really think through the problem areas and the needs in the MLOps pipeline. As you can see here, there are really just a lot of research out there that speaks to how there are a number of challenges today in enterprises adopting machine learning and deploying models to production. And perhaps chief among them are the tripod of productivity, performance, and scale. In fact, when it comes to productivity, 75% of enterprises build their own AI models in-house. They hire experts and they really try not only to build the models, but build some of the tools that they need to develop such models and bring them to production. So there is a lot of in-house development that requires a level of productivity and collaboration among these modelers and practitioners. Then we see and we heard through a number of interviews that we've done, and I'll share with you verbatim in the coming slides some of those pain points in the words of our customers, we hear that there is a significant performance issue in the sense that teams spend a significant amount of time, on average 6 to 9 months, working on projects. But yet 2 out of 3 of those like modeling projects fail to make it to production for all sorts of reasons. They don't comply with governance, or they take a lot of time to get to certain results, and there is very little visibility into understanding such results and explaining the behavior of models, etc. So performance has been a significant challenge for enterprises to adopt machine learning in general. And then scale is another need for enterprises, with close to 60% of teams getting to critical mass, reaching a point by 2021, end of 2021, early 2022, where there are at least 20 models in production. We're no longer talking about making one model work for the business. We're talking about ensemble modeling. And that's a whole other level of pain points and needs and orchestration along the life cycle. So as we read everything out there in terms of the hype and the challenges in this space, we went out on a discovery journey. We talked to our customers, we talked to a number of non-customers, really just to get a sense of their actual problems. And indeed, some of the things we heard is companies lose patience and fail before they go to production because, again, they don't have an ability to understand where the real issues have happened in the life cycle. Interestingly enough, modeling is not linear like software development. It's very iterative. And therefore, there is a lot of feedback loops and a cyclical nature to the work, unlike software development that is a little more linear in its process, if you will. Another thing we heard is with deep learning and neural networks, hyperparameter optimization is absolutely necessary, because it really delivers a significant impact with a fraction of improvement. You can have significant changes to the underlying business decisions that are being driven by the ensemble of models. And no better place where this is incredibly important for businesses than in trading firms, in algorithmic trading firms, in streaming media firms, cloud service providers. They really deal with very complex modeling architectures, and that very finite fraction of improvement is essentially a game changer. Another thing we heard consistently is that because the talent is still scarce, and companies go to extreme lengths to really attract experts, you end up with a practitioner team, cross data scientists, machine learning engineers, that are, they have a fragmented expertise across different tools in the tool chain. And this is an industry where there is just a massive number of tools that continue to get produced and published, and from open source to freemium to paid offerings. And you have these diverse skills, and you really don't want your practitioners in the team to actually waste the time trying to learn new tools. You want to empower them and allow them to hit the ground running, and give them an abstracted workbench where they can all bring that expertise and still be effective in collaborating, still be focused on the strategies of modeling rather than on learning a new tool to use. And we've seen this across a number of different businesses that are trying to embrace machine learning and bring models to production. So what does that really mean? If I were to summarize, the problems are modeling, as I mentioned, it's non-linear, it's very artisanal, it's a research-like process. And therefore, for such development environment, you really need an ability to organize and track the work and transcribe everything that has happened, so you can recall certain strategies or certain steps with perfect recall, if you will. Another problem is trade-offs. How do you make trade-offs? How do you basically visualize results? And based on those visualizations, you as a practitioner learn alongside the model itself. As the model is learning over time and training and tuning and retraining and retuning, you as the modeler get to a place where you are learning how your strategies and your decisions are eventually impacting the evolution of that model. So how do you analyze those results? How do you explain them to your colleagues and to management? And how do you come to a place where there is understandability and explainability in this very kind of black box nature of models gone to training, if you will? And then lastly, the third class of problems we heard is it's really tough to get modeling right because there's just far too many moving parts. Data itself is a very dynamic element of modeling. And there is a need to train, tune, collaborate, and iterate as you do that. So it's not like you train linearly and then you're done and you reach an ideal result. There are a lot of strategies and decisions along the way that require like revisiting and fine tuning. So that really needs a set of tools and a workbench that allows you that seamless navigation between training, tuning, and collaborating with others. So along those problems, we've really developed a solution that alleviates some of these challenges for modelers and enables MLOps in the enterprise. And the core area of focus for us is really to help basically track the entire modeling pipeline from the time you begin developing a model when your data is ready to basically featurizing that data, to training the model, maybe choosing different architectures and testing out from a training perspective which architecture is best suitable for the data set you have, doing some evaluations, doing some basic level tunings. SigOpt comes with grid search and random search packaged, so you can try simpler tuning mechanisms before you decide to maybe do further training and then go back and fire off hyperparameter optimization tuning so you can achieve that best model. And we do believe that this model development aspect of the life cycle, or what I would love to refer to as model engineering, is incredibly important to getting that model right. It's incredibly important to really soliciting that collaborative and productive aspect of how practitioners come together to deliver an ideal model for the problem statement that they are trying to solve against. So how does this really play out in terms of capabilities that we package in our product? We have an experiment management solution that really allows you a set of advanced visualization techniques that helps you with the training, retraining, tuning, retuning. But it's also modularly integrated with our hyperparameter optimization. This is the area where SigOpt is the leader today in the industry with 6 years of history, really building a solution that supports various industries, clients globally, and have been tested in some of the most demanding environments like algorithmic trading and financial trading in general. So I want to show you from a modeler standpoint, what does it mean to actually use SigOpt solution today? And this demo is available also on YouTube. The link is here. But I want to go through it live. So one of the things I do as I collaborate with my team on a modeling project, I want to show you this fraud detection use case. And this is like my homepage for my project. I come in here, and this is an opportunity for me to see the latest results that that came through experiments I've conducted, experiments my team members have pushed, training, all sorts of strategies explored, if you will. And this is a really interesting landing page that helps me get the top best results for one of my most important metrics, the AUPRC, for this fraud detection problem. And it shows me that, for example, this first best result, and interestingly enough, as I hover here, it shows me the bars underneath. So you can see where that particular experiment landed. And I can look here. There are 20 actual runs nestled within this experiment, and it's an XGBoost optimization, a hyperparameter optimization, and it is the one that produced the best result thus far in this entire project. But as you can see here, I can, from this high-level summary view, I can get a sense of how the work is progressing. I can progress to look at a specific experiment. This is that best experiment, and it shows me all the observations along the way. And it gives me a sense of what happened. As you can see here, I fired this off a few minutes ago. But one thing that comes to mind is like, okay, so how do you come into this dashboard? How do you end up here? Like, you're probably working in your notebook or through the command line. How do you end up here? Let me quickly go back and show you from my demo notebook here the connection into all the work I'm doing and how it shows up in SigOpt. So this is my fraud detection use case. First action I do is I import my libraries, and as you see here, SigOpt is important. And I named my project there. There's a step of data cleaning. I'm going to skip through some of these data steps to really show you the model development strategies that I have employed here and how I get to visualize those at SigOpt on the dashboard. So first thing I do, or after I analyze my features here, I'm going to quickly get to the modeling decisions here. So I'm defining my metrics. F1 score, AUPRC are my primary metrics. There are a few other metrics I want to set up here for this project to just get a sense of what's happening as the model is training. And my first decision is to choose between two architectures, an XGBoost architecture or a deep learning architecture. I'm not sure which one is going to work best with my data set. And I'm using a synthetic data set from Kaggle here. So first thing I do is I run a simple training run using XGBoost model architecture. And that gives me this finished run. So I'm going to click on that. It allows me to go to SigOpt. And in this page, I get a visual of what happened with that first training run, the performance. And it's actually highlighted in this light blue because obviously there were a number of experiments and training runs that have been conducted. But here it shows me exactly where this particular one landed in the universe of all the training that has transpired. I can see my metrics. I can see some basic information about this particular project. It does tell me that this is not an optimization run. It gives me parameter values, metadata, the data set connected to this particular training, the code. We've heard a lot of modelers care about this. And then the logs, as well as the API object. I can also choose to archive a run. So after I do a lot of work, maybe some of the work for me is no longer needed, and I want to archive it so that my project only reflects some of the work that I still want to understand or analyze with my colleagues. So that's my first run. As you can see here, my metrics, I'm going to just focus on AUPRC and the F1 score. They're not ideal. So this, to me, is telling me, let's go see how the deep learning model is going to perform. I'm going to basically do a training run with a Keras deep learning model, as you can see here in my code. And then this shows me that the run started. I'm going to go see the completed run to get a sense of what happened. This is a deep learning run. So the first visual I get is really checkpoints and how they transpired. And then the expected dashboard layout of having the performance values of the graphs of that particular run, and it shows me where it landed here in relation to everything else. These metrics don't look better than the XGBoost. So already I am seeing just from this quick review of results that XGBoost is possibly a better architecture for the data set I'm using than this Keras deep learning model. It's not an optimization, and everything else is as you have seen before, same expected level of information gathering and tracking. Okay, so I'm gonna go back and I'm gonna go to my XGBoost and perform a simple grid search just to see if the optimization improves the actual results. That's the experiment created, and that's the optimized grid search command. So let's grab any of these finished runs, and we'll get to see the whole experiment as well. So this is showing me, let's see, let's look at the whole optimization. So this is slightly better. It looks like I can improve upon what I had. I'm still not close to a really good result that I would like to share with my colleagues for us to discuss. But it's getting a little closer, and it's proving at least the point that XGBoost is a better architecture for a model for my data set. So here's what I'm going to do. I'm going to go back, design new features, and explore, after designing those features, a retraining of that XGBoost model and see what transpires. So let's go straight to that. Here's that finished run. And it's showing me where it's at in relation to everything. And as you can see, it's actually commanding some of the highest bars there. So as you see here, these metrics are already an improvement on where I started. So I feel like I'm onto something here, and possibly a SigOpt optimization can help me see if I'm gonna further improve on these metrics. Okay, so I'm gonna go back and activate a SigOpt hyperparameter optimization. And let's pick any of these finished runs. And we'll get to look at the whole optimization as well. Right. Okay, so this is already a much better value on my metric there. And you could see how that evolved over time. Okay, so this is interesting, but how does it really all come together? If I go back to my project page, there's a way for me to dig into the results of all of these like experiments and runs. And I showed you how I, all of the work, as I performed the work, it actually is tracked and saved in the SigOpt dashboard. But what about the work of my colleagues and their contribution? And I want to see basically how my strategies complement theirs, and how do we, like, how are we making our way to some of those best metrics? So one of the things you could do here from the overview page is you can go straight to the analysis page. And there are run table and experiment table. I'll speak to that in a bit. So in this analysis page, it shows me, based on all the runs that were conducted on this particular project, first of all, it shows me the checkpoints. So there are a couple of deep learning models. And the good thing about it is, as I hover on every point, it also shows me where those points lands in the graph that compares the metrics to parameters. And you can see like every single optimization experiment is color-coded. So I can discern where things landed. Since I'm not really, so this shows me some of the Keras deep learning model work. This shows me all the experiments and everything together. I can also look at the parallel coordinates. So what I'm going to do here is I'm going to remove some of those early feature metrics to get, yeah, this one. yeah, to get a sense of how my F1 score AUPRC really, how they evolved over time. All of this is fed through this run stable. And the run stable really captures every single, training experiment conducted. And it tells me there are about 76 of these. This is a lot of data. So one of the things I want to do is I want to create a filter, quick filter, where I'd like to make sure that I want to see results where my AUPRC is greater than 90%. That already, let's put that back. That already reduced that number to about 40 rows. And if I go back, so I'm going to save that view. And I think I just, yep, let me give it a name. Okay, so I can come back to that view later if I want to further zoom in. And what I'll do here is first I will graphs run filtered by table. I'm going to remove this. And it will start showing me results where the AUPRC is, yeah, there you go. So see here, AUPRC is higher than 90%. So it shows me actually fewer results. And this allows me to start really focusing on areas where the metrics are becoming interesting, like the work is really getting to better results. I can actually decide to, this is a very interesting point, so I'm gonna highlight it. And as I highlight it, it color codes it so that I can see all the other values for that particular point. These are dashboard widgets. You can add any dashboard widget. In fact, we're extending this dashboard to be able to add all sorts of capabilities for you to actually create your own plots, your own graphs, and your own analysis of the underlying data. And this is a default project dashboard, but if I were to want to look at a specific model or a specific experiment, or an ensemble of models within a particular project, I can do that. So, yeah. Lastly, we are working on adding a conversational piece where you can include notes, and in those notes you can attach files and documents and images, specifically if you have certain rich media data that is really important to clip onto a project so that your the larger team can actually work asynchronous with you and see what are some of the strategies you worked on. And this for like I recall one of our beta users saying this really saves a lot of those post-its, a lot of those strategies and notes that he takes everywhere. And it's sometimes very hard to put together and stitch together, and gives him that opportunity to recall all the work perfectly. I know exactly when anything has happened. And I can go back to the overview page, but below the results, there's always a log of the entire my activity. And if I go to the homepage, I can see also the activity of my team. Yeah, and it shows me their recent runs, their recent experiments, everything that is available to me here. So with that, going back. With that, I really want to summarize saying that really this, for me, it really gives modelers the opportunity to transcribe their work, visualize the results, and really inform their own intuition about their strategies, as well as over time learn how to explain and understand the results of that work. And then ultimately have the flexibility of training and tuning iteratively and still recall all of that work perfectly over time. And that is a plus in terms of productivity and collaboration. So with that, I want to thank you. And I want to open it up to any questions.
Thanks, Faye. Thanks, Rob. Before that, we actually got two separate questions, Rob, during yours, but I caught them a little bit late. And they actually go hand in hand. So I thought I'd bundle them together, or I think they go hand in hand. The first question related to how you, or which of those problems that you laid out, or which of the tools that you identified in your landscape come up as the most pressing issue for your customers that you engage with. Like, what is top of mind for people? What do they focus on? What's the top priority? What's the biggest stumbling block? And then the second question, I think that's what this question was about. The second question was more related to your customers, like which industries they're in. I actually think those kind of go hand in hand. So I think it's trying to get perspective on where your insights are coming from, more or less.
Yeah, great. I'm going to assume we're looking at kind of like the rainbow diagram of some of the functional areas that were sort of problem areas. And maybe I can go into more generic challenges that businesses are facing later on if we have time. But, you know, a lot of the discussions I'm having, you know, there are already the data scientist team on the ground. They're already building models. They might have a few lighthouse projects where they're seeing some value and benefits. So a lot of the work that my teams are helping out with is more around that feature engineering, automation, the data pipeline creation, the DevOps of sorts to be able to make sure we get that CI/CD up and running, both from a process and organization, but also from a technology and kind of a pipeline perspective. So that automation and standardization across teams has been a really huge area for us to focus on. What we're also finding is just migrating it up to a scalable platform, both for training and inference. So moving it, for example, up to GCP or AWS has been a game changer for a lot of machine learning groups who are still running a lot of stuff on their laptops. And Faye, I love that, you know, you got Anaconda up and running on your laptops. You're as guilty as anyone. You know, and I have the same thing. You know, you're running Docker on your laptop. People are building out massive forecasting platforms for, you know, I was helping one client in the oil petroleum, and they like, I think we need to move it up to the cloud. And I was like, yeah, probably. That'd be a great start. So I hate to say it, a lot of it still first principles. Let's automate. Let's build that reproducible pipeline and get you up to the cloud so you can start getting the benefits from there. So I think that's probably where we're spending a lot of the time. Feature stores is popping up quite a bit. And Nick, we were talking about this a few weeks back, but there's been some great platforms out there that are trying to make it super easy for you to build out a feature store. But a lot of the clients here in Australia built it up homegrown, you know, jerry rigging it on top of Teradata, and they're just having nightmare results from that. So I think we're going to see some growth in that feature store area too. Faye, I don't know if I put you on the spot, but that's a good kind of maybe topic around, like, you know, what challenges are you seeing when you go out and talk to clients? I imagine it's a little bit more focused on some of the core competencies, but I'm sure you hear everything.
Yeah, I definitely, I want to say about 70% of those I spoke to, they all really echoed the same need of empowering their practitioners through a workbench that really allows for different skill set to collaborate together, where someone is working through a command line, the other person is on a notebook, and they still can actually work together and see the results of their work and understand what happened under the hood and kind of explain their strategies and the results. So that definitely resonated top of mind. Another thing that keeps coming up, and this maps to exactly what you're seeing on your side, is the productionalization aspect of the life cycle. In fact, in December of 2019, NeurIPS did a recap of the conference, and they published that only 22% of attending companies have pushed models into production. So there is, and these are like attending companies. This is really core to their business. They all have practitioners. They're all building models. So really moving from R&D to production is definitely a significant challenge and a pain point. And it's the next thing that I hear significant demand for in terms of how to streamline it, how even simple things beyond like the governance and the compliance, how different it is when you're pushing models to the edge versus to the cloud, versus where there is maybe some more real-time data that the model may actually need to handle. Do they do that on the device? Do they do that at the cloud level? And like even the orchestration of the ensemble across, you know, these devices and environments is a very big challenge today for enterprises. So I'd say those are the two that stand out. I do also hear about feature store. I definitely echo what you see there. But at least top of mind, those are the two that consistently came up.
You know, and I guess in Silicon Valley, where the level of maturity is a lot different than what you see in kind of, you know, quote unquote normal parts of the world, the challenges were also completely different. And I imagine that leads back into the industry discussion. Certain industries and departments within industries are going to have vastly different needs and issues. But in Silicon Valley, some of my clients, it was more around a lot of the stuff that SigOpt, and this is why my head was nodding as Faye was going through it. We were building homegrown solutions that would help you manage the cross-validation across ensembles or multi-modes. And that was, you know, scripting the spin up of VMs, scripting the sampling of data, pulling it all together, loading the latest model, and then running it together. And then of course, loading that into a SQL Server database or some sort, and then putting some reporting on top of that. And as a consulting, that's great because that means man hours, but it's not very reproducible across multiple departments. So what we're finding is that tools like SigOpt that are offering that capability would help kind of itch that scratch quite a bit. So we're doing quite a bit of work around automating the cross-validation and then monitoring of it. And then I would also add on the routing. And once you get that model up into production, you get that scale. Now people are starting to ask questions on like, how do we leverage what we learned from marketing and start doing proper A/B testing or canary testing from rolling out new models and new variants? Well, that's a whole nother level of complexity. I built my model, it works really well. Look at the AUC, just push it to production. We're good. I'm going to go to Hawaii. And that's obviously not the case. So I mean, Faye was talking about the cyclical nature of DevOps and ML. Just getting a grasp of that, even in Silicon Valley, was a big issue. And it was still mainly manually executed in a surprisingly number of cases. From an industry perspective, you know, I've helped out across pretty much all the industries. I have to say petroleum and mining tends to have a very strong capability, you know, going back to the old days of where their core business in a lot of ways was around finding new wells to drill. So we're helping out a little bit more around the data. But if you go into HR or you go into supply chain or some of these other areas that have been kind of invested in, really fun, exciting discussions around using analytics to help identify everything from your most valuable employees, but also just do organizational network analysis and trying to start pulling together a lot of this great data that's coming together. So I'm really excited about those conversations, and those exist pretty much across the industries, you know, at the moment.
Great. Yeah, that makes a lot of sense. I think the other question that came through, Faye, for you relates to hyperparameter optimization. Which algorithm does SigOpt apply? Oh,
So
you're muted.
yeah, it's an ensemble of global optimization algorithms, Bayesian optimization, and a global ensemble that we've developed over the last 6 years, and kind of consistently won a number of industry awards for its its leadership on performance, on productivity, on scale, and on really achieving the best results for our clients. I think you can see on our website, there's the case studies of Two Sigma that really speaks to real world algorithmic trading needs, which are really significant in terms of the accuracy of some of the predictive nature of their modeling ensemble. And they're fully powered with SigOpt. We also work with government agencies, and we work with your most popular streaming service providers. Not necessarily at liberty to share all the names, but really a lot of what I call, when I look at the machine learning operations chasm, those early adopters and the innovators in the modeling space who have really very complex use cases, a lot of data, some sophisticated modeling architectures. They all have really signed up for SigOpt and used our product to further their modeling, their business, and the results that they are getting out of the solution. So I hope that answers the question, but also gives you a little more about some of those case studies that are available on our website.
Awesome, thanks.
Great.
That's those are all the questions that we had through the chat. So I appreciate your time tonight, and I appreciate everyone who joined tonight. I say because we're in the evening on the West Coast, but I know various times of day depending on where you're joining from. But thanks for joining us, and Rob and Faye, thank you for providing some of these insights through the process.
Thank you. Thanks,
everybody.
Bye.
Cheers. Bye-bye.